All right, so moving further, what should be the minimum delay constraints? So this is very interesting to see. So here I have a clock 1 and then the clock 2. Clock 2 the clock 1 and clock 2 have some T non-overlapping time, right? T non-overlapping time means we don't have any overlapping of between the clock 1 being high and clock 2 being high, right? Only when the clock 1 goes low, we will have the clock 2 going high, right? So of course there will be an overlapping for the clock being low, but that is not the definition of the T non-overlap. The definition of T non-overlap is both of them are not high at any point of time, right? Because that is what we are giving. We are giving the high level of the latch. So the latch is working in a positive level of the clocks. So both the latches L1, L2, L3 and so on are working in the positive level of the latches. So we have the definition of T non-overlap with respect to the high level of the clocks. So we have this clock 1 and clock 2 now. And let's say that we have a combinatorial circuit here also, which is nothing but similar to the combinatorial circuit 1. So I will write it as circuit number 1, or I can write it as the circuit number 3, which is, it's all the even odd numbers are same, goes to the latch number 4, right? And again, latch number 4, we will have the clock 2 signal, right? So let's say that we have the contaminated output, the D1, the Q1, the D2, and then the Q2, and then the D3 signal. So the D3 signal has arrived much earlier, right? So it has arrived much earlier here. And the Q3, which is the output of the latch 3, right? And remember that the latch 3 should work for the clock 1, right? And latch 1 should work for the clock 1, but the latch 1 will work in the, it is supposed or expected to work in the first clock edge, and L3 should work in the second, or rather the second clock level. So first clock level and then the second clock level, the L3 should work. So that's what I'm writing here, L3 and L1. All right, and for the phi 2, we wanted L2 to capture in the clock 2 first high level, and L4, the L4 should work in the second clock level of the clock 2. All right, so with that in mind, let's say that the D3 signal has arrived here, and then a D3 signal should be captured, D3, which is nothing but the L3's latch should capture it in the second clock level of the phi 1 clock. So D3 is here. So the Q3 will be with respect to the propagation of clock. Whenever the clock goes high, we will say that it will be it's a contaminated output. Let's say that we are taking into account the contaminated output because this is what the minimum delay constraints we are talking about. So with respect to the contaminated output, we have to see whether there is any hold time failures, and if at all there is a hold time failure, we need to add a buffer so that it avoids the hold time failures, right? So if I consider the very fast output, which is nothing but a contaminated output, so clock to Q, and here we are taking clock to Q because the D3 signal has already come and it is just waiting for the clock to do the transition, and then we'll get the output of Q3. All right. So if I have the clock Q3 here, and this will be the contaminated clock to Q for the latch number 3, which is nothing but similar to the design of the latch number 1, and that's why I've written as clock to Q. Instead of 3, I've written it as 1. Right? So because the designs of latch 1, 3, 5 and all the odd number of latches are still the same. Right, and after that we will have the combinatorial circuit number 3 passing the output here. So this will be D4. So my D4 signal will come after the contamination delay of the combinatorial circuit number 3, and we can assume that circuit number 1, combinatorial circuit number 1 and combinatorial circuit number 3, 5, 7, all of them have the same characteristics. Right, so in that sense the TCD1 is written instead of TCD3, and then we will get very close here, right? So this is my D4 signal. D4 signal is supposed to be captured in the second level of the clock, right? But if it is very, very close to the the first level of the clock 2, right? And it is closed in the sense that if it is falls within the t-hold time of the design for the latch 4, latch 2 and latch 6, which is having the same characteristics, if it falls within the t-hold time, then it can actually get sneaked in. Right, so the output here, D4 output, which we are expecting in the second level of the phi 2 clock, but it can get actually sneaked in the first level of the clock 2. Right, and to ensure that that doesn't happen, we have to make sure that TCD1 plus TCCQ1, right, or in this case TCD3 and TCCQ3 plus the T non-overlap should be greater than the T-hold time. Right, but I'm assuming that the combinatorial circuit number 3 and all the odd number of combinatorial circuits have the same characteristics, and the latches, odd number of latches and then even number, the odd number of latches has the same characteristics of the TCCQs, and then the TCDs are the same. So I can, instead of 3, I can write it as 1, and T non-overlap will remain the same throughout both the clocks. So it should be more than that of the T-hold time. So what we are supposed to design is the TCDs plus, which is of the combinatorial circuit, plus the TCCQ, which is actually given by our latch designers, plus the T non-overlap should be greater than the T-hold, or greater than or equal to the T-hold. Now what if the T non-overlap is 0, then we should make sure that the TCDs plus TCCQ should be greater than the T-hold duration. Same as that of the flip-flop designs. So if you remember the flip-flop design, so even for the flip-flops, we had this TCD should be plus TCCQ should be greater than the T-hold. Now the other condition is, what if the T non-overlap is negative, right? So if I go back to the previous slide, you can see that here the T non-overlap is positive. If it is negative, that means what I will have is the clock 1. So this is my clock 1. And clock 2 will have some positive overlapping time. Right? So this particular duration, we can consider it to be, of course, non-overlapping time, which is negative. Right? So in this particular negative, the T-hold, in this particular negative values, what is likely to happen is, so if I go back to the previous slide, if T non-overlap becomes negative, my TCD, which I have designed, which I'm supposed to design for the combinatorial circuit, right? So this becomes negative. So TCD plus TCCQ should be greater than T-hold minus T non-overlap, but the T non-overlap is itself negative. So this negative is going to go here and become more positive. So my TCD values is going to actually increase, right? So the TCD values can be higher compared to the other cases. So if T non-overlap is negative, if it has some positive overlapping time, the overlapping high time between the two clocks, then the TCD, right, has to be more. So what it really means is my TCD designs, or the designs for the combinatorial circuit, which I had much more relaxed design criteria in the earlier case when the T non-overlap was positive. Here it is actually ensuring that it goes slightly more, right? So remember that the propagation delay is always it's always more, and the contamination delay should be greater than this particular parameters, right? So my constraints of the propagation delay and contamination delay, right, should, we should have some kind of a difference there, but it is coming closer and closer if I have the T non-overlap to be negative, right? So I don't have that much of room now if the T non-overlap is negative. If it is positive, then we'll have much of a room here, because the TCD value turns out to be much less if it is positive value. So it will be very, very low. But if it is negative value, this TCD value will be higher, right? So the TCD that we want to achieve for the combinatorial circuit will be higher, and the design for the combinatorial circuits will not be as much relaxed as when it was for the non-overlapping time to be positive, right? So hope this is clear.